Hello and welcome to a Control Engineering exclusive interview. I'm David Miller, Content Manager at CFE Media and Technology, and today I'm going to be talking with Al Beydoun, who is President and Executive Director of ODVA. ODVA is a standards development organization and membership association whose members comprise a variety of industrial automation companies. Now, ODVA works to advance open, interoperable information and communication technologies in industrial automation. And today, the topic of my discussion with Al is going to be single pair Ethernet, henceforth known as SPE, and Ethernet Advanced Physical Layer, henceforth known as APL. So a little bit of background on SPE and APL for those who might not know. SPE is simply a form of Ethernet that uses a single twisted pair of wires, whereas other forms of Ethernet in the past have used 2 or 3 twisted pairs. And because of this, it has a smaller footprint, and the cabling can be run up to 1,000 meters without signal decay. So this makes it ideal for very expansive process industry environments, such as an oil field or a large wastewater treatment facility. APL, by contrast, is simply a variant of SPE, which is intrinsically safe via adherence to the IEC 60079 two-wire intrinsically safe Ethernet standard, which we know, of course, as 2Ys for short. So being intrinsically safe means that via limitation of the voltage on the wire itself, it cannot under any circumstances pose a risk of lighting a spark or explosion in an atmosphere that contains dangerous gases or dust that may be flammable or something like this. So Al is going to be talking to us about these technologies. He's also going to be mentioning some of their key technical benefits, what's necessary to implement them, and then some of the major applications we might see them being put to in the years ahead. So without further ado, I'm not going to talk anymore. I'm going to go ahead and cut over to that interview now. Hello, Al. Thank you for joining us.
It's my pleasure, David. Thank you for having me.
Absolutely. So I think the best place for us to start is simply by having you answer for our viewers what precisely are single pair Ethernet or Ethernet SPE as we often say, and Ethernet APL or advanced physical layer, and why are they important technologies to advance automation and control networking solutions?
Sure. So in general, if we start with the a good definition of single pair Ethernet is a 2-wire communication using Ethernet, obviously, and using both data communication and power over the same 2 lines. What's significant about this is that it really allows Ethernet to be used down to field devices and in automation environment. Obviously, it started in the automotive industry for reasons of cost and ability and space and so on. And we will talk about the various technologies. So there are different applications behind single pair Ethernet. We're going to talk about obviously the APL, the advanced physical layer, which is a very specific design built for the process industry with certain requirements. We'll cover those. But there are other applications, so if we talk about, specifically like the APL is a physical layer using single pair Ethernet based on 10 base T1L. 10 base T1L, basically, it's a 10 megabit per second speed. And specifically to the process industry, it has to be intrinsically safe, and it has to reach the requirements was designed that they want to be able to reach devices up to 1,000 meters, and you're delivering power and signals on the same two lines, power over data line technology. So those are some of the the specifics, and what's nice about this, because it's at the advanced physical layer, it allows more, many protocols to run over it. So Ethernet IP from ODVA perspective because this is a physical layer, and we're on basically Ethernet IP is SIP, which is Common Industrial Protocol that runs on physical layer. So it's kind of the application level. So Ethernet IP can run on APL physical layer, which brings all the benefits of Ethernet IP to the automation industry. And specifically, we're talking here about the process. And later on, I'll talk about other application in cabinet where you're restricted to small devices, limited in some capacity, or hardware and so on, and size. So this is again the importance of the single pair Ethernet is its ability to provide a solution that is cost effective using 2-wire and reduces weights and get you the connectivity to the devices at the field level.
I see. And tell me as well, what are some of the key technical benefits and trends that are driving the move to single pair Ethernet and Ethernet APL technology? And then following from that, what is the expected adoption rate among manufacturers going to be like?
Sure. So the benefits are many. We start with I mentioned cost saving. So the cost of the devices, the cabling, the connectors, the physical, the PHYs themselves, the chips. That's one. Then we talk about connectivity. So devices that are now connected to the internet, you're able to receive data and perform diagnostics, do prediction, failure predictions, and so many other things. So a lot of data analytics that can be done with being able to connect to these devices. And then we talk about the next question I think you asked is what is the rate of adoption? Well, IoT devices, it was expected that predicted that devices connected to the internet would reach back in 2020, we will reach 30 billion devices by 2030. So and look at where we are today, 2023, only 3 years into this, and we're already having that the number of connected devices is expected to reach 30 to 40 billion devices. So we're already reaching goals that beyond what was initially estimated, and that's mainly driven by the digital transformation, the need to meet Industry 4.0 requirements and connectivity. And there are so many other benefits that are derived from connecting devices and being able to do not just analytics. There are digital twins and other aspects of simulation and improvements of efficiency and productivity.
And I want you to talk to me as well about what SPE technology actually looks like in a real, tangible sense. And if someone wants to purchase and implement SPE technology, what exactly are they looking for?
Okay, so in its simple form, I mean, we're looking really at an ecosystem here. So we're looking at you would need devices that vendor making these devices that have these PHYs. So the first a chip that would support this physical layer. You're looking at the cabling. So you're looking at 2-wire, basically a single pair rather than the conventional 4 or 8 wire system. So you're looking at connectors. So there's an ecosystem that is built around supporting the SPE, and vendors would treat it just like any other purchase, in a sense that this is a new technology, new components, and new physical layer, and they would deal with it as a, like any other component strategy and supply chain, that they do in their normal business.
I see. And so to broaden out a little bit, talk to me too about what the impact of SPE and APL cabling is going to be on network topologies and on the type of network architectures that are possible. And what are going to be the advantages of some of those new approaches?
Sure. So for single pair Ethernet, obviously, this will enable the use of one application, the flat cabling. So the specific one here is we have an application where in cabinet solution, we call it. It's another way of describing it. It's constrained devices like push buttons, very simple devices. Now you're connecting those to Ethernet cabling. So these are very small devices, and this flat cable design, kind of a multi-drop, would offer a space saving. So you have kind of in an industrial environment, you have these cabinets where all these buttons and connected. So you have this flat cable that runs neatly inside the cabinet, and devices are connected on that flat cable, and there's select line and there's switch power and so on. So this basically offers devices that were previously hardwired, not connected to the internet, to be connected, to offer the diagnostics, and it's obviously cleaning up, offering a clean routing of wiring and space saving. So instead of all the wires, and that adds up in a automation environment where you have many of these cabinets, and now you have a one cable rather than all the other solutions. So that's one example. Another example from an APL perspective. APL, the majority of cases will use trunk and spur. So the trunk topology would run up to 1,000 meter. The spurs typically supports about 200 meters. And you could even use ring topology for non-powered network or non-intrinsic safe to enable redundancy. You could also, APL would support parallel PRP, or parallel redundancy protocol. So there are many possibilities depending on the application and the situation.
And since you mentioned applications, talk to me more about some of the specific application areas that SPE and APL solutions are actually going to be targeting, and also how these solutions can contribute to IoT and enterprise connectivity.
Sure. So we mentioned already the in-cabinet as a solution, or in-cabinet. This is an area where we invested obviously some effort, and we see this coming online very soon. This is an area where we had to basically modify, come up with specification to support this specific need, and use UDP communication, again, because these are smaller devices and so on. So this is really allowing so many new devices to be connected. On the process industry, I mean, this is basically a game changer, bringing Ethernet down to the field, so down to devices at the edge, and having the seamless communication, point-to-point communication, all the way to being able to provide the data upward to the back systems. I mean, this is adding so many opportunities and opening up endless opportunities for automation to connect new devices, both whether it's a discrete, hybrid, or in the process industry.
So we've talked a great deal about SPE and APL themselves. I think we've defined them well. We've talked about some applications, and I think we've fairly thoroughly also covered the benefits to automation and control engineers. But obviously, the other thing here is that they do require some supporting technologies to be in place, right? So tell me, what technological advances do you see as enabling the development and the deployment of SPE and APL solutions in the future?
Sure. First, with all these new standards, you have to have the organizations like ODVA. You have to have the effort taken place to develop and release the standards, so vendors can use them consistently. And from ODVA's perspective, we have conformance. So we have to develop the conformance testing required to ensure that these devices being built to these new standards meet the requirements, and to ensure that the end users will not have any issues in their environment. So standards needs to be developed and released and available to vendors who intend to manufacture, design, and sell these devices. The other thing is, the entire ecosystem of cabling, and the semiconductor has to, you have to have a cost effective, so you want the volume, the higher volume, to bring the cost down and increase the adoption. So this is an important one, that you have the supply chain of the semiconductor, the PHYs, also the cabling. So the cabling, obviously now manufacturers of in the cable industry, they have to come up with the two wire systems and connectors. So you have to have the connection at the end of the day. So there are other partners and other players in the industries that are ensuring that all these pieces are coming together to enable the adoption, and at the end of the day, bringing this technology to life.
And what are the specific technical benefits that this technology provides that will enable adoption of SPE rather, versus what's possible with typical applications today?
Sure. So there are, the benefits we can talk about, compared to the conventional, whether it's, the cost, and if you're talking about, the 4-wire or 8-wire system. So there's really weight and cost of cabling. It's by itself is significant when you add up the amount of wiring that goes into a manufacturing facility, and so there's also, when we talked about the actual, the devices, the PHYs will be cheaper, and vendors are able to make these devices cheaper. But there are other benefits that are very helpful for the control engineers, and commissioning, and speed, and bandwidth. So as a control engineer, I have the connectivity, so I could bring in devices on board much quicker. Configuration, commissioning now takes seconds rather than minutes, and so on. I have the ability to collect data and use the data for to improve, various process parameters, and enable other technologies, adjacent technologies. We talked about digital twin and so on. But there's so many things that supports that, and gives the engineers the benefits of collecting and analyzing the data, and making good sense of it and use it to their advantage.
And I think this probably gets at the impact that SPE will have on smart manufacturing and IIoT and things like that as well,
Absolutely.
right?
Absolutely, absolutely. At the end, right now it's all about connectivity. It's about data, making the data visible, and this is the first step. Is you have to you connect the devices to the internet, make the data available so it can be used effectively.
I see. So before we conclude, I do just want to ask you one more thing. And that's if you could provide for me a brief overview of how ODVA in particular works on advancing SPE and Ethernet APL technologies.
Okay, so ODVA, we are an international standard development organization. We have nearly 400 members globally. They represent the largest industrial automation vendors. And our members, basically, they participate in working groups. And this gives them the ability to share their knowledge, help to advance and solve pain points for the industry, for their end users and so on. So having this, the ability to bring players and members together to solve these pain points. And we have several of these working groups depending on what technology, what their interest is, whether it's single pair Ethernet, whether it's the physical layer areas, or so various areas, many ways they can get involved and help support the development of these new technologies. So this is how at the end of this process, obviously we are developing and releasing these specifications for everyone to use. So everyone will benefit. The industry the entire industry will benefit from this effort.
Okay, so I think we've covered a lot of material. Unless there's anything else you would like to add before we conclude, I think we can go ahead and wrap this up.
Yeah, no, thank you for having me. This is really a very important topic. This is a game changer. SPE has a huge potential in the automation in other areas as well. We will see this growing and continue to grow because of all the benefits we discussed that it will bring to the industries.
Okay, so
Thank you for having me.
Oh, yes, absolutely. And I want to thank you for joining us. And I want to also thank all of our viewers and listeners for taking the time to sit down with us too. So Al, thank you very much. And to all our viewers and listeners, thank you as well.
My pleasure. Thank you.